Good morning students. Let me welcome you all to my last video on the chapter solid state. So far we finished 14 videos on the chapter solid state. So here it is the 15th video, and of course the last video of this particular chapter. Of course here in the last video I am going to concentrate on one important property of solids, that is what we call it as magnetic properties of solids. And this is the today's discussion, right? Magnetic properties of solids, and you can expect a few questions on this particular topic, in the annual examination as well as in the competitive exams, right? Remember, as far as magnetic properties are concerned, these are the properties which will be depending upon the behavior of the solids towards the magnetic field. And as far as electrical properties of solids are concerned, that is the properties which depend upon their behavior towards electric field. Now it is the properties of solids which depend upon their behavior towards magnetic field. That is what we call magnetic properties. How these substances behave when they are exposed to the external magnetic field. Depending on that, we have different types of substances. That is the solids are classified into different types of substances. Before going to that particular aspect, let me see why solids exhibit magnetic properties. Why these solids should exhibit magnetic properties. ಹೌದಾ? ಈ solids ಅಲ್ಲಿ magnetic properties ಯಾಕೆ ಬರ್ತದೆ ಅದನ್ನ ಸ್ವಲ್ಪ ನಾವು ನೋಡೋಣ. ಆಗ್ಬೋದಾ? Right? ಈಗ ನೋಡಿ, as far as solids are concerned, they are characterized by atoms. Solids ಅಂತ ತಕ್ಷಣ ಏನಿದೆ ಅಲ್ಲಿ, they are characterized by atoms. As usual, atoms are characterized by electrons, right? Now, as far as electrons are concerned, in an atom, we have nucleus, right? This is nucleus and right? Yes. Electrons are revolving around the nucleus in closed circular path. That is what this is orbit. Yes. In that particular orbit, electrons are revolving around the nucleus. Say, for example, this is nucleus, right? This is nucleus, right? And here it is an orbit in which electron is moving. Yes, in which electron is moving. Yes, right? This is nucleus, and here it is electron. Here it is electron. This is electron, right? Okay, now, say for example, the direction of the electronic movement is like this, right? This is orbital motion, we call it as. Electron is revolving around the nucleus, okay, in a particular orbit, that is called as, yes it is energy level, or you can say orbit anta karithವಿ. So that is due to this electronic movement. Look at this, any moving charged particle is characterized by magnetic field. Any charged particle that is moving is characterized by, yes, it is magnetic field. Look at this electron is moving, in this direction. Yes, in this direction. Okay, na? Then if I apply thumb rule for that, if I apply thumb rule for that, look at this. Electron is moving like this. That is in the anti-clockwise direction, like this. Okay, na? Yes, that is, look at the direction of the thumb. In the opposite direction, that is like this. Direction of the thumb will be like this, and this is the magnetic field. Direction of the magnetic field generated due to the, yes, it is orbital motion of electron. Yes. Okay, now due to the orbital motion of electron, yes, that magnetic field is generated in the perpendicular direction. Yes, it is. This is what we call direction of the magnetic field from north to south. Yes, that means electron is characterized by two magnetic dipoles, that is north and south, and that electron is acting like a tiny magnet. That electron itself acting like a tiny magnet. That is, this moving electron is like a current flow. Okay, that moving electron, when it is revolving around the nucleus in a particular orbit, and magnetic field will be generated. Yes, it is. Substances exhibit what we call it as yes, it is magnetic properties. Apart from that, look at this. This electron, which is revolving around the nucleus, right, is characterized by spin motion also. As far as magnetic properties are concerned, the magnetic properties here, the spin motion, the contribution of spin motion is very, very important, and that is more important than, yes, it is contribution of orbital motion. This is orbital motion. Its contribution to the magnetic property is very, very less. Okay, na? And those aspects you are going to study in the chapter D block elements, right? We come to spin motion. See, consider, yes, it is one electron. Yes, this is electron. Yes, this is electron. Yes. Okay, now, and it has got its own spin motion like this. This is spin motion, that is what we call it as spin motion is characterized by quantum numbers minus of and plus of, and this is what we call anti-clockwise direction. This is what we call it as anti-clockwise direction. Yes, therefore idu anti-clockwise direction is, therefore magnetic field will be in this direction. This is magnetic field. This is magnetic field due to the spin motion. This is magnetic field due to the spin motion. Yes. This is magnetic field due to the spin motion in anti-clockwise direction. Yes. If I take one more electron like this, one more electron, yes, and its spin motion is in the opposite direction, that is in clockwise direction. Yes, in clockwise direction. Clockwise direction ಅಂತ ತಕ್ಷಣ ನೋಡಿ ಇದು ಆಂಟಿ ಕ್ಲಾಕ್ವೈಸ್. ಈಗ ನೋಡಿ ಉಲ್ಟಾ ಮಾಡಿ, that is ಉಲ್ಟಾ ಮಾಡಿ, that is ಈಗ ಈ ತರ yes, anti clockwise direction, that is magnetic field will be in the opposite direction, that is from here it is, this is from north to south, and of course it is from north to south, that is the magnetic field, you know, the direction of the magnetic field will be from north to south, and of course the strength of the magnetic field will be expressed in terms of what we call it as magnetic moment. The strength of the magnetic field will be expressed in terms of magnetic moment, that is called as mu b ಅಂತ ಕರಿತೀವಿ. ಅರ್ಥ ಆಯ್ತು ಅನ್ಕೋತೀನಿ ನೋಡಿ. And of course electron is characterized by two types of spin motion. This is spin motion in anti-clockwise direction with a quantum number minus of. This is spin motion with a clockwise direction with a quantum number plus of, right? Okay na? If the spin motion in anti-clockwise direction, look at the magnetic moment, direction of the magnetic moment is like this. If the spin motion is in clockwise direction, look at the magnetic moment in the opposite direction, that is, okay na? So that is what we call it as the moving electron is characterized by magnetic moment, or it will generate magnetic field because of its movement, and that is due to the spin motion as well as orbital motion. Both are, you know, responsible for the magnetic moment of the electron. Both are responsible for the magnetic moment of the electron. But out of these two, the contribution of spin motion is more compared to that of the orbital motion. Contribution of spin motion is more compared to that of the orbital motion. Okay, now that's why this is very important for us. This is very, very important for us. Okay, now just imagine, as far as atoms are concerned, right? Atoms are characterized by what we call it as unpaired electrons and paired electrons. Howdalva? You know, in the case of unpaired electrons, right? All the spin motions will be in same direction. All the spin motions will be in the same directions. Unpaired electrons only. All unpaired electrons are characterized by what we call it as same spin. That is, they are spinning in the same direction. Howda? And that is, their spins will be added. Their spins will be added. If an orbital has got paired electrons, ಅಥವಾ if unpaired electrons are absent ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. If unpaired electrons are absent, ಆಗೇನಾಗುತ್ತೆ? If the unpaired electrons are absent, that is only paired electrons are present. If paired electrons are present ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. This has got, yes it is magnetic moment in one direction. This has got magnetic moment in opposite direction. ಹೌದಲ್ವಾ? If the atom contains only paired electrons ಇದ್ರೆ ಏನಾಗುತ್ತೆ? The magnetic moment of one electron due in one direction is cancelled by the magnetic moment of another electron in the opposite direction. ಹೌದು ತಾನೆ? ಹಾಗಾಗಿ ಏನಾಗುತ್ತೆ? The net magnetic moment experienced by the paired electron will be zero. The net magnetic moment experienced by the paired electrons will be zero. ಹೌದಾ? In such cases, you know, no magnetic field will be generated. ಹೌದಾ? But if the substances contain, if the atom contains, you know, unpaired electrons, ಏನಾಗುತ್ತೆ? All the magnetic moments will be in the same direction. All the magnetic moments will be in the same direction. Then the magnetic moments will be added together. Again, magnetic moments will be added together, and of course net magnetic moment will be increased. As I said, magnetic moment is measured in terms of one unit, that is called as Bohr magneton. This is a unit for expressing, this is a unit for measuring magnetic moment, that is what we call it as Bohr magneton. Yes, as far as Bohr magneton is concerned, it is written in terms of Bm, that is Bohr magneton, right? And it can be calculated magnetic moment, sorry. The magnetic moment will be calculated by using the formula, that is square root of n into n plus 2, that is in terms of Bohr magneton. Yes, this is magnetic moment, and it can be calculated by using the formula square root of n into n plus 2 Bohr magnetons, where n is equal to number of unpaired electrons. ಹೌದಾ? And as far as one Bohr magneton is concerned, yes, ನಾನು ಹೇಳ್ತಿರೋದು ಈಗ Bohr magneton ಅಂತ ಹೇಳಿದಲ್ಲ, one Bohr magneton ಅಂತ ಹೇಳಿದ್ರೆ, this one Bohr magneton is equal to 9.27 into 10 to the power of minus 24 ampere meter square. This is one Bohr magneton is equal to 9.27 into 10 to the power of minus 24 ampere meter square. And of course, this is the formula to calculate the magnetic moment in terms of Bohr magneton. Yes, in terms of Bohr magneton. One Bohr magneton is equal to 9.27 into 10 to the power minus 24 ampere meter square. Okay, now. So in the discussions we discussed so far, in these discussions, what we come to know that the magnetic properties of the solids is because of, yes, it is presence of electrons. Electrons are characterized by two kinds of motion, that is orbital motion and spin motion. Okay, na? These moving electrons around the nucleus, a moving electron about its own axis, that is spin motion, they generate magnetic fields in one direction. Yes, it is. And because of that, electron acts like a tiny magnet. That means electron is characterized by north pole and, yes, it is south pole. When that electron is placed in external magnetic field, the north pole of the electron is attracted by the south pole of the external magnetic field. The south pole of the electron is attracted by the north pole of the external magnetic field. And because of that, substances will exhibit magnetic properties. Because of that, substances will exhibit magnetic properties, right? Yes. And of course, this discussion only one question expect ಮಾಡಬಹುದು. Name the types of motion of electron responsible for the magnetic property of a solid. Two types of motion. One it is orbital motion, another is spin motion. Right? Now we'll go for the, yes, it is classification of solids based on magnetic properties. Right? This is the classification of solids based on the magnetic properties. Diamagnetic substances, paramagnetic substances, ferromagnetic substances, antiferromagnetic substances, and ferrimagnetic substances, right? So we'll see one by one how exactly these substances are, how these substances differ one another with respect to the magnetic properties, right? We'll take up first of all, that is diamagnetic substances, right? We'll go for the diamagnetic substances. These are the substances which will be repelled by the magnetic field. The substances which will be repelled by the magnetic field, they are called as diamagnetic substances. Any substance which is repelled by the external magnetic field, that is called as, yes, it is diamagnetic substances. Why they are repelled by the magnetic field? Because they do not contain unpaired electrons. They do not contain unpaired electron. Yes. They contain only paired electron. Yes. Imagine if the substance contains paired electron, right? If the substance contains paired electron, that is paired electrons will have opposite spins. That magnetic moment in one direction, yes. Okay, is cancelled by the magnetic moment in the opposite direction because these paired electrons have got opposite spins. These paired electrons will have opposite spins, therefore their magnetic dipoles will be in opposite direction, and therefore the net magnetic moment experienced by the substance is zero, and therefore they are not attracted by the external magnetic field, and they are called as diamagnetic substances. Example for that, we have many examples like H2O, right? And sodium chloride is there, yes. Nitrogen is there, right? H2O, sodium chloride, nitrogen, these are all the some, or you can say benzene, that is benzene. These are all the some substances which will be repelled by the magnetic field because these substances contain only paired electrons. This H2O, that NaCl, N2, benzene, and of course generally they are characterized by even number of electrons in their valence shell. They are characterized by even number of electrons in their valence shell. Here, water has got oxygen 6, hydrogen 2, 8 electrons in valence shell, right? Sodium 1, chlorine 5, 6 electrons in the valence shell, right? Nitrogen 3 plus 3, 2 nitrogen atoms, that is equal to 6, right? Nitrogen has got, 5 electrons in the valence shell, 5 electrons in the valence shell, right? Therefore, 5 plus 5, yes, it is 10, right? That is nitrogen. Even benzene, C6H6. Carbon has got 4 electrons in the valence shell, 4 into 6 plus 6 into 1. 24 plus that is equal to 30. That is, in the case of diamagnetic substances, the valence electrons, number of valence electrons will be generally even. Exceptions there. Best exception is oxygen and N. It has got 6 plus 6, that is 12 electrons in the valence shell, but still it is paramagnetic. That we explained in the case of molecular orbital theory. The exception is ಕೆಲವು ಕಡೆ ಎಕ್ಸೆಪ್ಷನ್ಸ್ ಇದೆ, ಓಕೆನಾ. ಹಾಗಾಗಿ ನೀವು ಜನರಲ್ ಆಗಿ ನಾನು ಬರೆಯೋದು ಹೀಗೆ ಅಂದರೆ H2O, NaCl, and of course yes it is nitrogen, benzene. They are examples for diamagnetic substances because they do not contain unpaired electrons, right? And all the electrons present in these substances will be paired only. That's why they are diamagnetic. Okay, now we'll see paramagnetic substances, right? Right? We'll say paramagnetic substances, right? Paramagnetic substances are the substances which will be weakly attracted by the magnetic field. Yes, they are weakly attracted by the magnetic field. Yes, they are weakly attracted by the magnetic field. Yes, or you can say they are attracted by the magnetic field. They are called as paramagnetic substances. Weakly ಅಂತಂದ್ರೆ ಮತ್ತೆ ಕನ್ಫ್ಯೂಷನ್ ಮಾಡ್ಕೋಬೇಡಿ. ಈ weakly ಅಲ್ಲ, ಇದು ವಾರಕ್ಕೊಮ್ಮೆ ಆಗುತ್ತೆ ಮತ್ತೆ. Weakly WEEKLY ಅಲ್ಲ, WEAKLY. Yes, weakly attracted by the magnetic field. Weak. They are not strongly attracted by magnetic field. That is what we call it as weakly attracted by magnetic field because they are characterized by unpaired electrons in their atoms. They are characterized by unpaired electrons in their atoms, right? They are characterized by unpaired electrons in their atoms, right? ಇವುಗಳಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, the atoms of these substances will be characterized by unpaired electrons. You know, if unpaired electrons are there, ಏನಾಗುತ್ತೆ? All unpaired electrons will have, that is spin motion of all the unpaired electrons will be in the same direction. All unpaired electrons have got their spin motion in the same direction. ಹೌದಾ? ಆಗೇನಾಗುತ್ತೆ, that the magnetic dipoles will be added together. Magnetic dipoles will be added together and thereby the net magnetic dipole moment increases and therefore that will be attracted by the magnetic field. ಹೌದಾ? ಹೇಗೆ ಅಂತಂದ್ರೆ, so for example imagine one solid, ಓಕೆನಾ. ಸೊ ನಿಮ್ಮ ಎಕ್ಸಾಮ್ಗೆ ಇವೆಲ್ಲ ಡಯಾಗ್ರಾಮ್ಸ್ ಏನು ಬೇಕಾಗಿಲ್ಲ, ಬಟ್ ಏನಪ್ಪ ಅಂತಂದ್ರೆ ನಿಮಗೆ ಒಂದು ಕನ್ವಿನ್ಸ್ ಆಗಲಿ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ನಾನು ತೋರಿಸ್ತಾ ಇದ್ದೀನಿ. ಒಂದು ಸಬ್ಸ್ಟೆನ್ಸ್ ನಿಂತ್ಕೊಳ್ಳಿ. ಎಸ್, ಹಿಯರ್ ಇಟ್ ಈಸ್ that is dipole moments, that is electrons in an atom. Yes, electrons in an atom. Yes, they are having that spin motion in one direction, right? Okay na? Yes, ಈ ತರ ಒಂದು ಸ್ಪಿನ್ ಮೋಷನ್ ಇದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. That is what we call as electrons have got, that is magnetic dipoles in like this randomly distributed. Yes, the magnetic dipoles will be randomly oriented. Yes, randomly oriented in different directions. That is, this is one atom, this is another atom, this is another atom, one more atom, like this they are randomly oriented. ಹೌದಾ? ಓಕೆನಾ? ಇದೊಂದು sample of a paramagnetic substance, right? When I place it in external magnetic field, this is north pole and it is south pole. Yes, if I place it in external magnetic field, ಏನಾಗುತ್ತೆ, direction of the magnetic field will be from north to, yes it is south. The direction of the magnetic field will be in the north to south. ಹೌದಾ? Yes, it is north to south. This is the direction of the magnetic field. Yes, when they are placed in magnetic field, ಏನಾಗುತ್ತೆ, and of course the atoms will be, the dipole moments will be, or you can say that magnetic dipoles will be oriented. Some of the magnetic dipoles will be oriented in the direction of the magnetic field, external magnetic field. Some of the magnetic dipoles will be oriented in the direction of the external magnetic field. That is some of the, like this. Some will be like this. Okay, some will be like this in the direction of external magnetic field. Yes, some. All magnetic dipoles will not be oriented in the direction of the magnetic field. Some of the magnetic field will be directed. Magnetic dipoles will be directed. They are oriented along the direction of the external magnetic field because the thermal energy of the substance, every substances are characterized by thermal energy at a given temperature. The thermal energy of the substance doesn't allow some of the dipoles to be oriented along the external magnetic field. ಸಬ್ಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ಏನು ಥರ್ಮಲ್ ಎನರ್ಜಿ ಇರುತ್ತಲ್ಲ, ಅದು ಆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಡೈಪೋಲ್ಸ್ ಅನ್ನ ಒಂದೇ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಅಲೈನ್ ಮಾಡಲಿಕ್ಕೆ ಬಿಡೋದಿಲ್ಲ. ಹಾಗಾಗಿ ಸಮ್ ಆಫ್ ದಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಡೈಪೋಲ್ಸ್ ವಿಲ್ ಬಿ ಓರಿಯೆಂಟೆಡ್ ಅಲಾಂಗ್ ದಿ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ and therefore they are weakly attracted by the magnetic field. Example for the paramagnetic substances will be, yes, it is oxygen, O2, and of course Cu+2, Cr+3, Fe3 plus, right? These are all the examples for, yes, it is paramagnetic substances because they are weakly attracted by the magnetic field. Yes. ಅರ್ಥ ಆಯ್ತು ಅನ್ಕೋತೀನಿ. ನಾನಿಲ್ಲಿ ಏನು ಬರ್ತಿದ್ದೀನಲ್ಲ, ಇದು ಎಲೆಕ್ಟ್ರಿಕ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಡೈಪೋಲ್ ಆಫ್ ಒನ್ ಆಟಮ್ ಅಲ್ಲಿ, ಓಕೆನಾ. ಇನ್ ದ ಅಬ್ಸೆನ್ಸ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಏನಾಗಿರುತ್ತೆ, ದೇ ಆರ್ randomly oriented in the given substance. When they are placed in the external magnetic field, some of the magnetic dipoles will be oriented along the direction of the external magnetic field and therefore they are attracted by the magnetic field. Therefore they are attracted by the magnetic field. ಹೌದಾ? Yes. Okay na? ಈಗ ಬನ್ನಿ. You will come to know why I have highlighted this particular point. ಯಾಕಂದ್ರೆ next I have to explain one more important aspect, that is what we call ferromagnetism. ಅದಕ್ಕೋಸ್ಕರ I want to differentiate paramagnetism and ferromagnetism. ಅದಕ್ಕೋಸ್ಕರ ಇದನ್ನ ನಾನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ಓಕೆನಾ? ಇರಲಿ, ಇದನ್ನೇ ನಿಮಗೆ ಎಕ್ಸಾಮಿಗೆ ಕೇಳಲ್ಲ, ನಿಮಗೆ ಇಷ್ಟನೇ ಎಕ್ಸಾಮಲ್ಲಿ ಕೇಳೋದು. ವಾಟ್ ಆರ್ paramagnetic substances? Give examples. Substances which are attracted by the magnetic field, they are called as, yes, it is paramagnetic substances, and of course this is because of the presence of unpaired electrons. Examples, these are the examples, right? Now come to the ferromagnetic substances. Ferromagnetic substances, right? Look at this, ferromagnetism. Ferromagnetic substances, right? And these are the substances which will be strongly attracted by the magnetic field. Ferromagnetic substances are the substances which will be strongly attracted by the magnetic field. They are strongly attracted by the, yes, it is magnetic field, because the atoms of these substances are containing more number of unpaired electrons. Atoms of these substances will be containing more number of unpaired electrons. Right? For example, if I take Fe there, an atom of Fe is characterized by 4 unpaired electrons, right? Cobalt has got 3 unpaired electrons. That is, examples for the ferromagnetic substances will be iron, cobalt, yes, it is nickel, yes, it is gadolinium, that is Gd there, and apart, yes, it is these are the, yes, it is examples for CrO2, chromium oxide, that is, these are the examples for, yes, it is ferromagnetic substances, right? Unpaired electron really there. Ferromagnetic substances are characterized by unpaired electrons. Paramagnetic substances are also characterized by unpaired electrons, right? But still, there is a difference in the magnetic properties. How the ferromagnetic substances are strongly attracted by the magnetic field. Paramagnetic substances are weakly attracted by the magnetic field. How the? Adhan explain madlike I'll go for it, right? Look at this. This is a sample of metal, right? This is a sample of metal. It's a sample of solid. The solid sample, okay na? Idರಲ್ಲಿ I just divide this particular sample of solid in different regions, right? ಈ ತರ ನಾನು ಏನು ಮಾಡ್ತೀನಿ, divide ಮಾಡ್ತೀನಿ, and of course I'm going to group this particular solid. Yes, I'm going to group this particular solid. Yes, it is depending upon, yes, it is this solid is characterized by, yes, it is atoms, right? Okay na? And in the case of ferromagnetic substances, you will find a group of atoms. You will find a group of atoms with their magnetic dipoles in the same direction. Look at this. And here it is. This is a group of atoms will have magnetic dipoles in one direction. Yes. Here it is a group of atoms. Here it is a group of atoms. They have magnetic dipoles in one direction. These two are different. But all the 3 atoms in this particular group, all the group of atoms will have their magnetic dipoles in one direction. Look at this. ಈ ತರ ಇರಬಹುದು. ಇದರಲ್ಲಿ ಈ ತರ ಇರಬಹುದು. Yes, ಇದರಲ್ಲಿ ಈ ತರ. This is what we call it as, in ferromagnetic substances are characterized by the group of atoms with their magnetic dipoles in one direction. ಈ ತರ ಇದೆ, and the directions of the groups will be different. Direction of the groups will be different. But within the group, ಒಂದು group ತಗೊಂಡ್ರೆ all atoms will have their magnetic dipoles in one direction. That is such type of group of atoms. Such type of group of atoms, right? Such type of group of atoms, right? Okay na? Such type of group of atoms with their magnetic dipoles in one direction. They are called as, that is called as domain. And such type of group of atoms with their magnetic dipoles in one direction, that is called as domain. ಅಂತ ಕರೀತೀವಿ. ಆಗ್ಬೋದಾ? When this particular, yes, it is substance when this particular substance, right, is placed in external magnetic field. I am going to apply external magnetic field. This is North Pole and this will be South Pole. Yes. If I place this substance in external magnetic field, right, that is direction of the magnetic field from north to south. Yes. Okay na? Okay na? Therefore, nodi, once they are placed in this particular, yes, it is that is external magnetic field. Yes. Look at this group. All the group of atoms will have their, yes, it is magnetic moments. Yes, it is will be aligned in the direction of the magnetic field. Yes, all the domains, atoms of all the domains, yes, will have their magnetic dipoles in the same direction. Yes, ಏನಾಗುತ್ತೆ ಈಗ ಎಲ್ಲ dipoles ಏನಾಗ್ಬಿಡ್ತವೆ, they are directing towards, yes, it is the magnetic moment of the external magnetic field. The direction they are oriented along the direction of external magnetic field. Now all the group of atoms, all the domains will have their, yes, it is the magnetic dipoles in the direction, again, similar to that of the external magnetic field. Therefore, in the case of ferromagnetic substances, right, in the case of ferromagnetic substances, all the domains will be, yes, it is all the domains. E group and I'll write like this. And this is one domain, two domains, three domains, four domains, and yes, it is yes, five domains. This is one group, okay na? This one group, right? And this group of atoms, will form one domain. Yes, that group of atoms will form one domain. Yes, magnetic substances, all the domains, right, will be oriented in the same direction. Look at this. This is what we call it as one domain. Yes, okay na? This is what we call it as another domains, and of course magnetic moments of all the domains will be in the same direction. Yes, and that is what we call, they are oriented in the direction of external magnetic field. Therefore, all the domains are oriented in the same direction. Therefore, the net magnetic moment or the net magnetic moment will be very, very high. The net magnetic moment experienced by the substance is very, very high, and therefore they are strongly attracted by the external magnetic field. That is what we call ferromagnetic substances, right? ಅರ್ಥ ಆಯ್ತು ಅನ್ಕೋತೀನಿ. ಓಕೆನಾ? ನಾನೀಗ ಈ ಗ್ರೂಪ್ ಆಫ್ 3 ಐಟಮ್ಸ್ ತಗೊಂಡಿದ್ದಲ್ಲ, ಅದು ಇದೊಂದು ಡೊಮೈನ್. ಈಗ ಇವು ಮೂರು ಒಂದು ಡೈರೆಕ್ಷನ್ ಹೀಗಿದೆ, ಇದು ಹೀಗಿದೆ, ಇದು ಹೀಗಿದೆ. all are orienting in same direction. That is what we call ferromagnetic substances, that is. Whereas in the case of ಅರ್ಥ ಆಯ್ತು ಅನ್ಕೋತೀನಿ. ಓಕೆನಾ? Whereas in the case of, yes, it is antiferromagnetic substances, right? Antiferromagnetic substances, right? So see that. That is antiferromagnetic substances. Antiferromagnetic substances, right? In the case of antiferromagnetic substances, right, equal number of domains will be in opposite direction. Equal number of domains will be in opposite direction. Look at this. Equal number of domains will be in opposite direction. Yes. Equal number of domains will be in opposite direction. Yes. Look at this. ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೀನಿ ನೋಡಿ, ಈಗ 6 ಡೊಮೈನ್ಸ್ ಇದೆ, 3 ಡೊಮೈನ್ಸ್ ಅಪ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಇದೆ, ಇನ್ನು 3 ಡೊಮೈನ್ಸ್ ನೋಡಿ, ದೇ ಆರ್ ಇನ್ ಆಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್. ಎಸ್, ಡೌನ್ವರ್ಡ್ಸ್. ದಿಸ್ ಈಸ್ antiferromagnetic substances. In the case of antiferromagnetic substances, yes, equal number of domains will be in opposite direction. Yes, equal number of domains will be in opposite direction. ನಾನೀಗ ಡೊಮೈನ್ಸ್ ಬಗ್ಗೆ ಡೀಟೇಲ್ಸ್ ಹೋಗಲ್ಲ, ಅವಾಗ ಹೇಳ್ಬಿಟ್ಟಿದ್ದೀನಿ. ಓಕೆನಾ? This is 3 in the upward direction, remaining 3 will be in the downward direction. Therefore, equal number of domains will be in opposite direction, and therefore they are called as, yes, it is antiferromagnetic substances. And of course, when equal number of domains are in opposite direction, their magnetic dipoles will be cancelled. Their magnetic moments will be cancelled each other, and therefore net magnetic moment of this substance will be 0, and therefore it is strongly repelled by the magnetic field. Strongly repelled by the magnetic field. That is what we call antiferromagnetic substances, right? Example for that is, it is MnO, and it is FeO, and the COO, that is examples for antiferromagnetic substances, right? And one more thing I forgot, in the case of ferromagnetic substances, they are strongly attracted by the magnetic field, and of course, they exhibit permanent magnetic property. That means even though the external magnetic field is removed, they behave like a permanent magnets. Therefore, these ferromagnetic substances are permanently magnetized. They can be permanently magnetized. That means even after removing external magnetic field, they behave like magnets, and that is what we call it as another important aspect in the case of ferromagnetic substances. Because in the case of ferromagnetic substances, all the domains will be oriented in the same direction, whereas in the case of antiferromagnetic substances, the domains will be in opposite direction, and therefore they are not attracted by the magnetic field, and that is what we call antiferromagnetic substances. Now at this moment, we'll go for the next one, that is ferrimagnetic. See that ferrimagnetic substances, now in the case of ferrimagnetic substances, look here, unequal number of domains will be in opposite direction, right? In the antiferromagnetic substances, equal number of domains will be in opposite direction. Yes, that's why the net magnetic moment was 0 there. But here in the case of ferrimagnetic substances, unequal number of domains will be in opposite direction. Look here, 4 domains, first, third, 4 domains will be in upward direction, remaining 2 domains will be in downward direction. That is, unequal number of domains will be in opposite direction. That's why these substances are characterized by certain net magnetic moment, and therefore they are weakly attracted by the magnetic field. That is what we call it as ferrimagnetic substances, right? Example for that, it is magnetite. Example for that, it is magnetite. That is Fe3O4, right? And this Fe3O4 can be written as FeO dot Fe2O3. This is what we call it as, in this case, magnetite. One iron will be in +2 state, another iron is in +3 state. That is what we call it as magnetite. And we come across certain substances called, a class of minerals called ferrites, with the general formula Fe2O4. This is general formula of ferrites, similar to that of magnetite, where M stands for any divalent metal ion like Zn +2, Mg +2, and of course Cu +2, right? Cu +2. Then and of course these are the examples for ferrimagnetic substances, right? For example, here in the place of M, if I keep Zn here, Zn Fe2O4, this is an example, one of the ferrites. Okay, na? Like that, in the place of M, if I keep magnesium, that is Mg, and it is Mg Fe2O4, it can be written as ZnO Fe2O3, and this can be written as MgO, yes, it is Fe2O3. This is what we call it as ferrites, and of course they are examples for ferrimagnetic substances. So that's the ferrimagnetic substances. Okay, right. We'll see next. Magnetic properties there, and apart from that, here we have one small term that is called Curie temperature. Yes, Curie temperature is the temperature at which ferromagnetic substance becomes paramagnetic. Curie temperature is the temperature at which ferromagnetic substance becomes paramagnetic, and that is called as Curie temperature. As far as iron is concerned, Curie temperature for iron is 1043 kelvins. When ferromagnetic substance is heated, when the temperature goes on rising, the structure of the domains will be collapsed. Now, domains anteli. A group of atoms with their magnetic dipoles in same direction, adella domains alla destroy agbidutte with a rise in temperature. Magnetic moment, magnetic dipoles will be in different directions, and the net magnetic moment experienced by the substance will be decreased. Therefore, that is what we call ferromagnetic substance is converted into paramagnetic. That is called as Curie temperature. For cobalt, it is 1394. This is, yes, it is. One more example for the, yes, it is the Curie temperature. Yes, the Curie temperature is the temperature at which ferromagnetic substance becomes paramagnetic. Yes, that's all. Yes, so that's all. Okay, na students, ಈ ಒಂದು 15 videos ಅಲ್ಲಿ I tried my level best to convince you people the concepts of the chapter solid state. Yes, ಓಕೆನಾ ಇದಕ್ಕೆ ಸಂಬಂಧಪಟ್ಟಂತ ನೋಟ್ಸ್ ಅನ್ನು ನಾನು ನನ್ನ ಯೂಟ್ಯೂಬ್ ಚಾನಲಿನ ಡಿಸ್ಕ್ರಿಪ್ಷನಲ್ಲಿ ನೀವು ನೋಡಿದ್ರೆ ಒಂದು ಲಿಂಕ್ ಕೊಟ್ಟಿರ್ತೀನಿ. ಆ ಲಿಂಕನ್ನು ಬಳಸ್ಕೊಂಡು ನೀವೇನು ಮಾಡ್ಬೋದು, ಯು ಕ್ಯಾನ್ ಹ್ಯಾವ್ ಯುವರ್ ಓನ್, ಎಸ್ ಇಟ್ ಈಸ್ the PDF of my notes on solid state. That is question to answers. Okay, na? So that is what we call it as solid chapter solid state. Okay, in the next videos, I am going to start what we call it as the chapter alcohols, phenols, and ethers. Agboda? Yes. Thank you.